Hello. 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 Okay. So welcome to the Studify Plus, our next session on the last two port parameter, and that parameter is known as ABCD parameter. Why ABCD parameter is very important? ABCD parameter, also known as transmission parameter. This parameter is useful for cascading of the system. When systems are cascaded, you can directly multiply the cascaded system using two port parameters, this ABCD parameter. So let's talk about our next very important parameter, also known as two port parameter. So here our next parameter is known as two port parameter, which is known as T parameter or ABCD parameter. Parameter is T parameter or ABCD parameter. Or also known as, always remember, used for cascaded system. When systems are cascaded, you can have the equivalent T model using the multiplication of the matrices. So we will talk about that. T parameter, or also known as ABCD parameter, or you can say this is known as transmission parameters. And this is useful for analyzing the transmission line, model the transmission line. What is useful for T parameter, useful for useful to model transmission line. This parameter is useful to model the transmission line, and that parameter is known as ABCD parameter or known as T parameter. So let's talk about this, how we can define the ABCD parameter. So we are having here our two port network, and in this two port network we are having this is our two port network, and in this two port network we are having two input terminals. 1, 2, 3 and 4. Correct? So here we are having two port network. How we are defining the input voltages? So this is our input V1. This value is known as I1. What is another value? Another value is we are having V2. This value is I2. Correct? How we can define the T parameter? So you can say the T parameter is defined by this. V1 I1 V1 I1 is defined as, how you can define the V1 I1? V1 I1 is defined as A, B, C, D times of V2 and minus of I2. Always remember, here the direction of current is not inside the network, it is going outside, but our parameter is defined for this. If this is our arrangement, we are taking the value of I2 as negative. We are taking the value of I2 as negative value. And why this when we define the two-port parameter, for the cascading of lot of networks, then getting equivalent of that cascading arrangement is very simple from this two-port T parameter model. So this is A, B, C and D. These are parameters. V1, I1 as V2 and minus I2. Here we can say V1 and I1 are dependent variable. Dependent variable means what? We need a voltmeter and ammeter to calculate this. And V2 and minus I2s are known as independent variable. V2 and minus I2 are independent variable. So this is the whole idea of having this parameter, ABCD parameter. Now let's go to this. How we can write V1? So converting this matrices into the equation form. So you can say what we are having, V1 is equivalent to AV2 minus BI2, and I1 is known as CV2 minus of DI2. This is two equations. So how we can analyze this ABCD parameter? So to analyze the ABCD parameter, your output port is acting as an independent port. So you have to apply a short circuited output port and you have to apply the open circuited output port. So we can say step number 1 is to apply V2 equal to 0, or you can say short circuited output. We have to apply what? We have to talk about short circuited. We have to apply a short circuited the output, and by making V2 equal to 0. So if you make V2 equal to 0, you are having this. By making V2 equal to 0, you are having ratio of V1 divided by minus I2. This is by making V2 equal to 0, and this parameter is known as, if you are making V2 equal to 0, V1 divided by I2, and this parameter is known as B parameter. Correct? What is next parameter? By making V2 equal to 0, you are having the ratio of I1 divided by I2, I1 divided by minus of I2, by making V2 equal to 0. So you can name it. This is you can say this is short circuit reverse current gain, or you can call it attenuation, but you don't need to focus on the name, because name varies when you apply this on some network or some specific task. So I1 divided by minus I2, I1 divided by minus I2, and that parameter is known as D. So by replacing your output port by short circuit, you can calculate two parameters, and these parameters are B and D. So these are two parameters. One parameter is D, and another parameter we are having is this B. What are remaining two parameters? Remaining two parameters by making step number 2. And what is step number 2? Step number 2 is what? Step number 2 is replacing I2 by 0. Replacing I2 by 0 means you are replacing your output port by open circuited port. Replace your output by open circuited port. So if you make I2 equal to 0, we are getting ratio of V1 divided by V2. V1 divided by V2 ratio by making output is equal. You can call it reverse voltage gain, but name is meaningful when you are having specific tasks. When you are calculating it for a specific device. So V1 divided by V2 by making I2 equal to 0, and this parameter is known as A. You can call it reverse voltage gain. And what is one more parameter? So one more parameter we are having here is this. One more parameter by making I2 equal to 0. So when you make I2 equal to 0, I1 divided by C2. One more parameter is known as I1 divided by V2 by making I2 equal to 0. This parameter is known as C. This is ABCD parameter. But what is the main application of ABCD parameter? Let's see how we can calculate ABCD parameter. We can check everything for this. This is ABCD parameter. A, B, C and D. What is the unit of A? So unit of A is unitless quantity, volt by volt. What is unit of B? It's a impedance, trans impedance. What is unit of D? It's unitless quantity, ampere by ampere, and this is also conductance or admittance. You can say both are valid here. Now, how you can define? So both in this case only you are replacing your output by open circuited and short circuited output, and you are calculating these parameters. How these parameters are related to the Z parameter or Y parameter or H parameter? This is the first task we need to perform. Because that relationship will give you the condition for symmetric and reciprocal network without any calculation. That is we want to know. The next thing is what? What is the most important property of this ABCD parameter? That when ABCD parameters comes in the cascade, that gives the multiplicative effect. Let's see these 2 points. So first point is relationship between. So we are having our ABCD parameter. Here we are having our ABCD parameter. And here we are having our Z parameter. So for ABCD parameter, how we can write? V1 is equivalent to AV2 minus BI2 and I1 is equivalent to CV2 minus of DI2. And what we need to do, we need to establish a relationship of this ABCD parameter with what? This conversion is possible. This conversion is very much possible. We can have conversion from ABCD parameter to Z parameter and Z parameter to ABCD parameter or Y parameter, anything. So you can say here we are having V1 is equivalent to Z11I1 plus Z12I2 and Vt is equivalent to Z21I1 plus Z22I2. What is the first parameter? The first parameter we are having is T parameter. And second parameter we are having is Z parameter. Second parameter we are having is Z parameter. And here in Z parameter we can say V1 and V2 both are functions of what? V1 and V2 both can be represented as a linear combination of V1 and V2 both can be represented as linear combination of I1 and I2. And here also we can do the same thing. So when I go to this equation, when I go to second equation, V2 is represented, can be represented as a linear combination of I1 and I2. So we are establishing the relationship between T parameter and Z parameter. We are having the, we are trying to establish a relationship between these two parameters. T parameter and Z parameter. We are trying to establish a relationship between T parameter and Z parameter. Now let's see how we can do this, how we can perform this. So what is the value of V2? When you look at this equation, V2 can be represented as a linear combination of I1 and I2. So let me write the second equation. I1 is equivalent to CV2 minus of DI2, and when I add this I1 plus DI2, this is equivalent to CV2, or you can say V2 is equivalent to I1 divided by C plus D by C times of I2. Correct? What I am saying, if I am writing the two-port equation for the same network, so for same network this value or this value must be same. If you are writing the voltage V2 across a network, if you are writing the voltage V2 across the network and V2 are having these two equations, so for a single equation you cannot have two values, so these two equations must be same. So can I say this value, which is obtained from which parameter? This is obtained from T parameter, and one more value which is obtained from Z parameter, which value is this? This value is V2 is equivalent to Z21I1 plus Z22I2. This two value must be same. And if this two value must be same, because we are equating the equations, don't think that we are open circuiting and short circuiting anything. We are just comparing the equation, and the equation will not change. So can I say for a linear network, of course. So when you compare these two values are for same two-port network, and these are the values of V2 and V2 for same network. the value of output voltage cannot be different. So what is the coefficient of I1? The coefficient of I1 is 1 by C here, and it is Z21. So you can say the Z21 parameter is equivalent to 1 by C. What is the coefficient of I2? The coefficient of I2 is Z22, and Z22 can be written as D by C. Here it is Z22 and here it is D by C. So we are trying to establish the relationship between Z parameter and ABCD parameter. So this value is one of the parameter and this is another. These two are equation. Okay, what is next? Next we want the relationship between what? Next we are having one more equation. And what is that one more equation? We are having V1. But I want V1 as a function of I1 and I2. Here we are having V1 as a function of V2 and I2. I2 is desired one, but V2 is not desired one. So let's replace V1. When we go to the next page, can I say, from T parameter I am writing the equation. From T parameter, what is the equation? From T parameter we are having the equation this. V1 equal to AV2 minus of BI2. And what is the value of V1 from which parameter? From Z parameter. So you can say from Z parameter what is the equation from Z parameter? The equation which I can write is this. V1 equal to Z11 I1 plus Z12 I2. So we have to compare these two equations, but what is the problem here? V2 is the problem. So let's replace the V2. Can I say V1 is equivalent to A times of V2. We want I1 and I2 as independent variable, and here is V2. So we can replace the V2. What is V2? V2 is again available in form of I1 and I2. So I can say this is I1 divided by C plus D by C times of I2. This is A times of V2 minus of B into I2. Minus B into I2. And when I represent this as a function of I1 and I2, so when I take I1 as a common, what I will have here? It is A by C. And when I take I2 as a common from here, if I take I2 as a common from here, I can say this is A into D divided by C minus B. Now what I am saying, both the equations are written for the single two-port network. For a given two-port network, if both the equations are written, then can I say this equation must have the same value. If these equations are having the same value, we can compare this to. So the coefficient of I1 is Z11. So can I say if coefficient of I1 is Z1, then you can say this coefficient is Z11. So Z11 is coefficient of I1, that is what? A by C. And what is coefficient of I2? The coefficient of I2 is Z12. So you can say the Z12 is given by AD divided by C minus B, or you can say this value is equivalent to AD minus BC divided by C. AD minus BC divided by C. Correct? And now this is the relationship between, what? This is the relationship between Z parameter and ABCD parameter. This is the relationship between Z parameter and ABCD parameter. So suppose for a given network, if for a given network You can write Z parameter like this also. If I am talking about Z11, what is the value of Z11? The value of Z11 is A by C. What is the value of Z12? Z12 is, okay, for ABCD parameter, can I say, if ABCD parameter is given by this, a 2 by 2 matrix, then can I say, the determinant of this matrix is what? AD minus BC. So AD minus BC can be represented as determinant. So A is written, what is value of B? Z11 is now Z12. Z12 is what? AD minus BC, which I can write determinant divided by C, of course. Now Z21, what is Z21? Z21 is 1 by C. This value is 1 by C, and Z22 is D by C. Z22 is, what is Z22? Z22 is D by C. Can I say this is the two-port parameter for, this is Z parameter of the two-port network. This is which parameter? This parameter is known as Z parameter of two-port network. This is the Z parameter equivalent. So can I say, if these two parameters are defined for the same network, then the condition of reciprocity and symmetrical network can be easily explained. A network is a symmetrical networks. What is the condition for symmetrical network? The condition for symmetrical network is very simple. Z11 equal to Z22. So you can say A by C equal to D by C. C and C cancel. So a ABCD parameter if ABCD parameter is given and let's say network is symmetrical, then what condition you will obtain? You will obtain this condition that A is equivalent to D. This is the first condition. What is the second condition? Second condition is the condition for a reciprocal network. And when a network is said to be a reciprocal network, for a reciprocal two-port network, what is the condition for reciprocal network? The condition for reciprocal network is what? Z12 is equivalent to Z21. Or you can say these two parameters are equal because this is the Z parameter of the given for same network. Correct? So you can say 1 by C equal to del by C. So 1 by C is equivalent to del by C. C and C cancel, del is equivalent to 1. And what is del? Del represents the determinant, which is AD minus BC value is equivalent to 1. AD minus BC is equivalent to 1. This is the idea. Now AD minus BC is equivalent to 1. This is the condition for a symmetrical network. So if a network is a symmetrical network, the ABCD parameter will satisfy this condition. Correct? And a network is, means if a network is symmetrical, a two-port network is symmetrical, this will be symmetrical using, you will get the symmetricity using Z parameter, using Y parameter, using H parameter, using ABCD parameter. All parameters will convey you same information. Okay, this is one of the theory for ABCD parameter. You can convert this into Y parameter also, and story is same. Suppose you want to convert this into Y parameter, which theory you will use? You will represent I1 as a function of V1 and V2. You will represent I2 as a function of V1 and V2. Now let's go to the next thing. And what is next thing? Next thing is very important. For that purpose, the ABCD parameter is very important, and that is known as cascading of ABCD parameter. cascade of T parameters. Okay, the idea is cascading of ABCD parameters. Cascade of T parameters. So we are interested in what? We are interested in cascading of T parameters. So how we can cascade T parameters? Let's talk about that. Suppose we are having, let's take the example of two ABCD parameters. So this is one, this is second. Okay, this is we are taking to ABCD parameters. We are taking two different T parameters. So we are taking two different T parameters. So here I am taking one, two, three, 4, 5. Okay, two T parameters are cascaded. Let's say two T parameters are cascaded. This is the idea, and I am calling this as a T prime. I am calling this as V1. I am calling this current as I1. Then we are having what? There we are having, let's call this as a V1 prime, I1 prime. Then we are having this is a V2 prime. This is I2 prime. And another two-port network for which T parameters are defined. I am representing it by T double prime. And there is a definition of T prime and T double prime. So you can call this as a T double prime. And how you can define it? You can define like this. This is V1 double prime. This is I1 double prime. And another value we are having is V2 double prime, and this value is known as I2 double prime. This is the whole agenda for which the T parameters are very important when you are having the cascading of two networks. So cascading of two port networks, and when you are cascading, you can get means suppose you are interested in the equivalent of this complete setup, then complete setup can be obtained using the multiplication of this two T parameters. So let's talk about this. How we can write from this equation, what I can get this. that value of V1 prime, value of V2 prime, value of V2 prime and V1 double prime is same. This value is same. Why this value is same? Because this value represents the potential of the same point. If this represents the potential of the same point, you can say these two values are same, and if these two values are same, these two values are same. What else we can say? Else we can say that I1 double prime is equivalent to minus of I2 prime. Why I can say this? I can say this because this represents the current in the same branch but in opposite direction. So current in the same branch must be same, and if it is going in the opposite direction, you have the negative sign. Correct? Now let's write the separate T parameters for both the two-port network. This is the network number 1. And this is network number 2. Correct? So can I say for first network, T parameter for network number 1. We are writing the T parameters for what? For T parameters for network number 1. Correct? And what is T parameter for network number 1? For network number 1 we can say, because what are the input port of a network number 1? These are the dependent variables. So you can say V1 prime, I1 prime, V1 prime, I1 prime can be represented as A prime, B prime, C prime, D prime times of what? V2 prime and I2 minus I2 prime. This is the two-port T parameter for first network. And what about the cascaded second network? So you can say for cascaded second network we are having this arrangement. For cascaded second network I am using this pen. What is input port? So you can say the input port here is V1 double prime and I1 double prime. So you can say we are having V1 double prime, I1 double prime, and this value is equivalent to A double prime, B double prime, C double prime, D double prime. This is multiplied by what? This is multiplied by what? This is multiplied by V2 double prime and minus I2 double prime. V2 double prime and minus of I2 double prime. What we did, we have wrote the two different T parameter for network number 1 and same for network number 2. For 2 we have written this. Now let's use the relationship. What kind of relationship we are having between these variables? V2 prime is equivalent to V1 double prime. So can I say V1 double prime can be written as, V1 double prime can be written as V2 prime. Can I say V1 double prime can be written as V2 prime? Fine. And minus I2 prime is equivalent to I1 double prime. So minus I2 prime, I1 double prime can be written as minus of I2 prime. Have you understood this? What I am saying, V1 prime, V1 prime, V2 prime and V1 double prime is the potential of the same node. So can I say V1 double prime can be written as V2 prime, and this represents the current at the same point. So can I say minus I2 prime? What is the value of I1 prime? I1 double prime can be written as minus of I2 prime. So we have taken the this relationship from here. Now, what is this value? This value can be represented as this value. This value can be represented as what? A double prime, B double prime, C double prime, D double prime times of this much times of V2 double prime, V2 double prime, and minus of I2 double prime. This is the whole agenda we are having. Now can I say, because I am considering V1 prime and I1 prime as my input, so let's take let's convert it into the standard format. What I am saying, let's replace V1 prime by V1 and I1 prime by I1. And let's take, because we are talking about the equivalent, we are talking about this, we are talking about this equivalent, that what is the equivalent of this, what is the equivalent of, what is the equivalent of this? We are trying to calculate the equivalent of this. So what I am saying, let's take V2 double prime as V2 and I2 double prime as I2. Then can I say V1 divided by I1, V1 and I1. So this V1 prime is V1, I1 prime is I1, and this value can be written as A prime, B prime, C prime, D prime, A prime, B prime, C prime and D prime times of this much times of V2 prime minus I2 prime column matrix. And what is value of V2 prime minus I2 prime column matrix? This value is A double prime, B double prime, C double prime and D double prime. And this is the final value. What is V2 double prime? So if we are talking about the equivalent of ABCD parameter, you can take V2 double prime as V2 and I2 double prime as I2. So you can say this is V2 and minus of I2. So what we are trying to convey? We are trying to convey that when two systems are given in the cascade fashion, when two parameters are given in the cascade fashion, what is the best idea to solve them? Find the T parameter and just multiply this 2 cross 2 matrix. So you can say, if I represent my whole system like this, 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 and this is, I am writing here a T equivalent. So can I say this value is what? This value is, I am writing V2. This value is, I am writing I2. This value I am writing as V1 and this value is I1. Then how you will define the T? So T, if I define T by A equivalent, B equivalent, C equivalent and D equivalent, or let me write a better idea is equivalent ABCD parameter this is given by what? This is given by this relationship A prime, B prime, C prime, D prime multiplied by what? A double prime, B double prime, C double prime and D double prime. So when you multiply this, you have to multiply this row column. So you can say here we are having A prime, A double prime and B prime, C double prime. This is row 1 column 1. Now row 1 column 2, or you can say this is row 1 row 2 column 1. So row 2 column 1, what is the entry of this? C prime, A double prime and this is plus D prime, C double prime. Then this is what the next element is. Next element you will obtain from row 1 column 2. So this is row 1 column 2. You can say this is A prime, B double prime, B prime, D double prime. And this is what? Row 2 and this is row 2 and column 2. Row 2 and column 2. So this is C prime, B double prime plus D prime plus D double prime. So just a multiplication of 2 cross 2 matrices, and that will gives you the final ABCD parameters for the given network. That will gives you the ABCD parameters for what? ABCD parameters for the given network. So this is the idea. What is the what is main use of this? What is main application of this? When parameters are, when two-port networks are cascaded, then you can, if you are having the T parameter, by just multiplying the matrices you can have the equivalent T parameter, equivalent ABCD parameters of the network. Now let's solve few of the question based on this ABCD parameters. So we have talked about the condition of symmetric network. We have talked about the condition for symmetrical networks, reciprocal networks. We have talked about the condition for which you can connect, how you can connect this. So always remember T parameters. All other parameters which are having connection is the resultant as addition of the resultant parameters. But here in T parameters, we just multiply when it appears in the cascade. So let's talk few questions based on this parameter, how we can solve the question based on T parameters. Let's talk about this. So let's go to the equation. Let's talk about few questions. Okay, this is the first question. This is one PYQ. This is one previous year question. What this question is saying, as passive two-port networks are connected in the cascade, okay, the cascade connection of because this is the property of the ABCD parameters, that when the two-port networks are in cascade and ABCD parameters are given, you can calculate the equivalent by You can calculate the equivalent just by multiplication of these two matrices. So can I say two passive two-port networks are connected in the cascade. The voltage source is connected at port 1. So this voltage is V1 and current is I1. And okay, this relationship is given. How they are defining V1? V1 is AV2 plus BI2 and I1 is CV2 plus DI2. V2 is AV2 plus V3 and I2 equal to CV3 plus DI2. Means for these two separate networks, means if I call this as T1 and if I call this as T2, the value of T1 and T2 is given. What is T1? The value of T1 is T1 is A1 B1 C1 and D1. And if I call this the second network as T2, for T2 what is given? A2 B2 C2 D2. A2 B2 C2 and D2. Correct? What I am saying, forget about everything. Are we able to answer this thing? Can we calculate the equivalent? Then we will talk about the what is A1, B1, C1, D1, A2, B2, C2, D2 are generalized circuit constant. If the Thevenin's equivalent. So if we are interested in the Thevenin's equivalent, what is basic theory? The basic theory is very simple. What basic theory says? If you are interested in the Thevenin's voltage, then replace your output terminal, remove the load and calculate the output voltage. Means by making I3 equal to 0, the value of V3 will be the Thevenin's voltage. One theory I can write here, Thevenin's equivalent theory. If I make I3 equal to 0, because when I calculate the resultant, what will remain here? Only V3 will remain here and I3 will remain here and V1 and I1 remain here. So if I make I3 equal to 0, the value of V3 is nothing but V open circuit voltage, or this same thing is known as V Thevenin's voltage. Correct? And how to calculate the Thevenin's resistance? That idea is also very simple. To calculate the Thevenin's resistance RTH, you have to make your supply equal to 0. So what supply we are having? So supply is equivalent to V1. So by making V1 equal to 0, the ratio of V3 divided by I3 will gives you the value of RTH. I am using the just basic principle of the Thevenin's equivalent. So how to calculate the Thevenin's equivalent? By removing the load, just to calculate the open circuit voltage, and that open circuit voltage is VTH. And by making your supply equal to 0, independent source equal to 0, the ratio of the test voltage divided by test current, and not I3, I should write minus I3 here, because we will apply the test source in this direction. So this will gives you the value of RTH. So this is the idea, but this you can apply with the equivalent two-port network. So equivalent two-port network T can be given by this. This is multiplication of A1 B1 C1 D1. This is multiplied by A2 B2 C2 and D2. When you multiply this, can I say this is A1 A2 B1 C2. This is row 1 column 1. This is again row 1 column 2. So you can say A1 A2, here you can multiply A1 B2 B1 D2. Here you can say this is row 2 column 1. So row 2 column 1 multiply is what? C1 A2 plus D1 C2. And here I can write C1 B2, B2 C1, D2 D1 D2. We can write the equivalent of ABCD parameter. This is the ABCD equivalent ABCD parameter. Now I can replace this whole thing by these values. So can I say, if I am having the two-port network, let's make it large. Can I say what is our two-port? A1 A2 B1 C2. Let's write it A. Let's write it B. Let's write it C. Let's write it D. Or let's write it A total, B total, C total, D total. We are writing like this. And what else is given? The else is given like this. V1 and I1. So input is connected as V1. So you can say here we are having V1. We are having V1 here. This value is I1. V1 I1. And what else we are having here? The output port is V3 I3. So here the output port is what? The output port is V3 I3. So just we have replaced our T parameter by equivalent, and this value is V3. And this value is what? This value is V3 and I3. Now, what is the value of A, T, BT, CT and DT? The value of AT, BT, CT and DT is given by this jargon. Now I can write the equation. Can I say the equation here I can write is this: V1 is equivalent to V1 is equivalent to V1 is equivalent to AT into I3 plus BT into AT into V3 minus BT into I3. Correct? And V2 can be written as A2 into, no, this is not V2, this is I1 can be written as CT into V3 minus DT into 3. Correct? Now we can calculate the Thevenin's equivalent. What is the idea of Thevenin's equivalent? The idea of Thevenin's equivalent is very simple. Just replace I3 by 0. If you make I3 equal to 0, the V3 will be what? Open circuited voltage. So can I say, if you make I3 equal to 0, this value is 0, this value is 0. So you can say, if you make I3 equal to 0, V1 is equivalent to AT into V3. And what is V3? V3 is nothing but your supply. Your supply is what? V1 is your supply. So you can say this is V1 divided by AT. And what is value of AT? The AT is this. AT means A parameter. So A1, A2, B1, C2. So you can say A1, A2, B1, C2. And this is what? This voltage is known as Thevenin's voltage. Always remember, the idea of calculating Thevenin's is very same as previous. What is the idea of calculating Thevenin's? The idea of calculating the Thevenin's equivalent is just remove the load from output. So as soon as you remove the load from output, the current is 0. So if current is 0, that voltage is known as open circuit potential, or you can call it VTH. So the first VTH, Thevenin's voltage, or open circuit voltage is what? Thevenin's voltage or open circuit voltage is given by V1 and not V1 this variable. This is supply. So V1 divided by A1A2 B1 C2. So let's go to the option. V1 divided by A1A2 B1 C2. This is available here. A1A2 B1 C2. This is available here. Not available in these two cases. So this is first and third option is wrong. Two options may be correct. Now we are interested in the Thevenin's equivalent resistance. What is the idea of calculating Thevenin's equivalent resistance? Make V1 equal to 0 and try to get the ratio of V3 by minus I3. So let's V1 equal to 0 in both the equations. So when I put V1 equal to 0, the first equation we are having is AT into V3 minus BT into I3. This is equivalent to 0. Correct? And here you can notice one more thing. This IT current is not going inside the network. This is coming out from the network. If this is coming out from the network, I should use plus sign here, because minus sign is taken when I3 is going inside the network. You can look at this. I am mentioning I3 current inside the network, that's why I am taking minus sign, but this is I3 current is given outside of the network, so you can use plus I3 here. If you can use this here, okay, if you can use this here, can I say ATV3 plus BTI3 is equivalent to 0. And by making V1 equal to 0, by making independent source equal to 0, we are only interested in what? We are only interested in the ratio of V3 and I3. So if this is equivalent to 0, AT into V3 can be represented as minus BT into I3. So you can say V3 divided by I3 ratio is equivalent to what? Minus BT divided by AT. And as you know how we are defining it, we are defining like this. What is ZTH? V3 by minus I3 ratio. So you can say V3 by minus I3 ratio is RTH, and that ratio is equivalent to what? That ratio is BT. What is BT? BT in this question is this: AB, A1 B2, D1 D2, A1 B2, A1 B2, B1 D2 divided by AT. And what is AT? AT is given by A1 A2, B1 C2. And this value is Z equivalent. So the idea is very simple. They just want to check whether you are able to answer this or not, that when two parameters are given in the cascade, what is the resultant. So you can say A1, what is option? A1 B2, A1 B2, D1 B1 D2, A1 B2, B1 D2. So which option is correct here? The option A is correct here, which is A1 B2, B1 D2, A1 A2 plus B1 C2. Fine. Let's talk about few more questions on ABCD parameters. Okay, this is question. This is again one PYQ, and this PYQ is taken from GATE 2025. What this PYQ is saying? This PYQ is saying that two passive two-port network P and Q are connected as shown in the figure. The impedance ZP is given for this first two-port network, Z parameter is given. For second two-port network, Y parameter is given. Let the ABCD matrix is alpha, beta, gamma and delta. Then what is the value of beta? Means they are talking about this. They are talking about what? They are talking about this R1, C2. Okay. But when two networks are given, we can multiply the T parameter only. But what is the given? The given parameters is Z parameter. So we have to convert Z parameter into T parameter. So let's convert it. Can I say Z parameter can be written as V1, V2 can be written as 40, 60, 80 and 100 times of what? I1, I2. So you can convert it into the T parameter very easily. You can say V1 is equivalent to 40 I1 plus 60 I2 and V2 can be represented as 80 I1 plus 100 I2. Correct? When we are talking about the T parameter, so in T parameter, how you define the T parameter? You can define the T parameter like this. You represent V1 as function of AV2 minus of BI2 and I1 as a function of CV2 minus DI2. So can I say, if I represent I1 here, if I can write the equation for I1. So first equation is what? V2 equal to I1 I2. Okay, we can compare this two equation. So can I say I1 plus DI2, from second equation we can write I1 plus DI2 divided by C is equivalent to V2. If this both values are value of V2 for the same network, this both values must be same. So what is value of 1 by C? 1 by C is equivalent to 80. I1 plus DI2 divided by C. And what is value of D by C? D by C equal to 100 and 1 by C equal to 80. So this is 100 divided by 80. This value is what? 5 by 4, 1.25. So value of C is known. C is 1 by 80. Value of D is known. Now for the first equation we want V1 as a function of V2 and I2, and here I can say the V1 is given as a function of I1 and I2. So I have to replace this I1. So how I can replace this I1? The value of the first equation can be represented as V1 can be written as 40 I1, and what is value of I1? The value of I1 can be written from here. Value of I1 can be written as here CV2 minus DI2. CV2 minus DI2. Or I can say what is value of V2? So what is value of V1? Okay, V1 is AV2 minus BI2. V1 equal to AV2 minus BI2. AV2 minus BI2. D and C are known. So AV2 minus BI2. V1 equal to AV2 minus BI2, and here also we are having V1 equal to 40 I1 plus 60 I2. So we are interested in value of V2. So you can say V1 is equivalent to V1 is equivalent to A times of V2. What is value of V2? The value of V2 can be written from here. I1 plus DI2 divided by C. I1 plus DI2 divided by C, and V1 equal to AV2 minus BI2, minus of BI2. Now you can say the whole function is available in which form? Whole function is available in A by C times of I1 plus D by, if I take I2 as a common, this is AD minus C minus B. Now what is given? A by C is 40. A by C is 40. And you know that what is value of C? C is equivalent to 1 by 80. So 40 divided by 80 is 1 by 2. This is the value of parameter A. What is next? AD minus BC divided by C. This value is given as 100. And C equal to what? 1 by 80. So AD minus BC equal to 100 divided by 80. What is value of A? 1 by 2. What is value of D? Value of D is 5 by 4. Minus B. What is value of B? B we have to identify it. What is value of C? 1 by 80. Equal to what? 100 divided by 80 means 5 by 4. 5 by 4. So 5 by 4 minus 1 by 5 by 4. So you can say this value will be what? Minus B into 80 is equivalent to 5 by 4 minus half of 5 by 4 is 5 by 8. And B equal to what? This is 10 minus of 50. So this is how you can convert. This is how you can convert your Z parameter into which parameter? ABCD parameter. Next parameter is given as Y parameter. You can convert Y parameter also in ABCD parameter. So when you get ABCD parameter, just multiply, only one term is required and that term is known as beta. Let's take one more problem. Okay. Okay, they are asking the condition for symmetrical and reciprocal networks. Okay, you can tell these conditions. Okay. One more question on ABCD parameter. What this question says, that we are having V1 I1 and V2 I2 for a two-port network. The port 2 is terminated by RL. So they are saying that we are having one two-port network. This is one two-port network in which we are having 4 terminals. 1, 2, 3 and 4. These are 4 terminals. What question is saying? Question is saying that the terminal 2 is replaced by a load RL. This is RL. So this value is V2 and this is I2. This value is given as a V1 and this value is given as I1. This is our two-port network. What they are asking now? They are asking that if output is terminated by RL, what is the input impedance? So input impedance is what? Input impedance is the ratio of input voltage divided by input current. So input voltage is Vi and input current is I1. So V1 divided by I1 ratio, in this ratio we are interested. From here, one equation we can write. If current is I2 is entering from the network, what is net outgoing current? That is also I2. So if current will enter from negative polarity, what is the value of V2? The value of V2 is minus of I2 into RL. The value of V2 is what? Minus I2 into RL. Now we can say, what is our equation? The V1 is equivalent to AV2 minus BI2 and I1 is equivalent to CV2 minus DI2. I am interested in the input resistance, means I am interested in this RI, which is ratio of V1 divided by I1, and V1 divided by I1 ratio is AV2 minus BI2 divided by CV2 minus DI2. Now can I say, if I take V2 divided by I2 ratio, the V2 divided by I2 ratio is what? Minus RL. So let's take I2 common from numerator and denominator. So if I take I2 common, this value is what? A times of V2 divided by I2 minus B divided by C times of V2 divided by I2 minus of D. Correct? I2 has been taken common and replaced by cancel by numerator and denominator. Now what I can say, V2 by I2 ratio is minus RL. So this is minus ARL minus B and this is minus CRL minus D. If I cancel minus sign, ARL plus B and CRL plus D, ARL plus B, ARL plus B and CRL plus D. Which option is correct? The option number D is correct here. This is correct option for the given question. So this is our analysis for two-port network, in which the connection is very important for every network. So you can say, any question remaining now? Okay. So we have tried maximum previous year questions of 2 marks, and we have talked about all parameters which is mentioned in your GATE syllabus, and I hope you have understood it. Thank you very much.